Today, I had the pleasure to speak with Pedro Teixeira, who is an MD PhD. Speaking of Dr. Know-It-All, right? Anyway, he's the co-founder and CEO of Prediction Health, which is using machine learning and artificial intelligence to improve medical outcomes. We talk about this, of course, about the business of AI and how AI will disrupt medicine, as well as a whole bunch of other industries. Let's take a look. Hey, y'all, it's Dr. Know-It-All. I am really happy to have Pedro Teixeira, and I'll let you say it properly because before we started recording, I was like, oh gosh, I'm going to sound like the whitest guy ever trying to pronounce your name. But anyway, he is an MD PhD. So if you think you're smart, then I guess, you got to compare yourself. This is a high bar that you have to compare yourself to. And so, yeah, you have two, medical degree and a PhD, and also are in charge of a company which is called Prediction Health. And so we're going to talk about that. The goal of Prediction Health is, as I understand it, at least from the outside, to combine the best of machine learning with good healthcare practices to hopefully improve everybody's healthcare outcomes. So, yeah. So anyway, introduce yourself a little bit about how you came about this, what your background was. Did you want to be a doctor when you were 5, or did you want to be a, astronaut or something? I don't know.
Yeah. So that's actually funny. So I'll start off, but I did briefly consider astronaut because space is so cool. And, that's obviously like probably one of those great, like nerdy kid things that you think about. But I grew up in Rhode Island, which is kind of a fun little quirky state to grow up in. And I think I was like 12 years old when I decided I wanted to go do MD and PhD. I basically heard about it, like, oh, did you know you could do this? And I was like, that's so cool. Because I thought medicine was fascinating. I thought health was super important. And I'd wanted to like be an inventor or something. And PhD seemed like the thing, that you would do if you wanted to be like an inventor, scientist, right? So I found out about that when I was really young, and I was just like, I have to do that. That sounds awesome because I probably just don't like to choose. So I just jam more stuff into my like list of things. So I can't say
it says something about you that you thought getting 2 advanced degrees was cool when you were 12. So
I was not the coolest kid on the block, but So I found out about that. And I was just like, I want to go do that. And, early on, I was like, oh, maybe I'll do surgery. I had a stint where I did like protein folding, but the motivation behind everything was I thought that health was just the most important thing. My parents would always say growing up that if you don't really have your health, then, all the other stuff doesn't really mean much because you can't enjoy it.
Right.
And, as parents sometimes do, they say stuff that really sticks with you. And I was like, well, I'm going to go try to be helpful and useful and help the health. And I then fell in love with all the programming computer science stuff in college. I took a course, I think it was sophomore year, and it was just amazing. It was just like, wow, I can get the computer to do so many things so quickly. I want to do science. I want to do medicine. This computer thing is just so cool. I'm going to figure out how to mush the 3 things together and do something useful with this. And just kind of ran the rest of the way with those 3 things in hand to try to improve human health. Yeah. And AI is kind of, another way that you can leverage prediction and useful stuff for the price of electricity at a scale that just, we don't operate in, right? We can't do trillions of operations per, hour or whatever.
Absolutely.
And so,
or hold on to the data that you have to hold on to be able to do that kind of stuff. Like, humans are rather poor with our memory retention. So, awesome. Exactly. So I saw I think it was 2017, you sent me that protein folding paper, which I attempted to read, and then I was like, oh gosh, this is hard. So, but it's like that, I don't know, before we get into your stuff, what is your take on, not AlphaFold. There we go. I was trying to remember I was like, not AlphaGo, but what is your take on that? Because that really, really upended the whole protein folding game.
Yeah. AlphaFold, it's incredible technology. When I was trying to figure out if I could get into any sort of MD PhD program, because there's not that many, my thing was I was gonna do protein folding. Again, it was like this crazy problem, folding the protein, because you start off a protein is just like a sequence of amino acids. So you have like this chain, like a pearls on necklace type thing, and it folds up, and the fold defines the function. So if it folds up into something that's going to go, chomp, glucose molecules off of glycogen, right? That's what it's going to go do. And I was just I just thought that if you have that sequence, you should be able to figure out. And like, of course, like you can. It's just like we hadn't like figured out quite how to do it yet. And so I had a phase where I was in a protein folding lab, and that was the problem. And I started kind of getting interested in machine learning at that point. And there was a great paper. It's about direct coupling information or direct information, where for a lot of proteins, you have thousands, like hundreds of thousands of sequences from all the different, species and creatures, right? And but it's the same protein. Like it sort of does the same thing. But because it's in all these different creatures over evolutionary space, it mutates. And so you get different sequences, slightly different. It's like the same theme, right? But you get some mutations here and there. But they can't all mutate equivalently. So if it's like a really important piece of the protein, like this is the binding pocket that does the chomping action, right? You can't just make a bunch of crazy changes there. If you're going to change anything, it still has to be functional. Otherwise, that creature is not going to be able to go pass that sequence along. And so you can infer how important the different pieces of the protein are by whether or not you see mutations across a lot of species. It's like, okay, so that's cool, right? I thought that was like really cool in and of itself. But if things are going to interact in a useful way, they probably have to be near each other in the final folded structure. So that phase of my life was take that direct information, take machine learning, take the sequence, and basically predict what parts of the protein seem like they're near each other because they have this evolutionary coupling in them. And therefore simplify the problem. Because now I know, like, okay, these things have to be at least near each other. So now instead of having to solve this completely unwound thing, I'm solving for this thing that's like partially wound up.
And the complexity with protein folding is, well, I mean, number one, it's a three-dimensional problem, so it makes it more complex. But also, it's just the sheer scale of this. These proteins are really long chains, and so every single link of the chain can fold in a bunch of different ways. So I mean, you've got this tree of possibilities that just is, it goes out into it's not infinite because clearly, AlphaFold managed to figure out a lot of it, but it's pretty nuts. But that, it's. I think that this is actually, even though it's not, current with what exactly you're doing now, it's just one of those indications of how radically artificial intelligence and machine learning are changing the nature of what we do so quickly. I think it was a video I was watching about it, and somebody said, folding a protein was $1 million in one PhD. Like you send a grad student off, and it's like, here's your, dissertation. This is your thesis project. Go do this. Fold this one protein, and you get a bunch of funding from NSF, and you spend $1 million in 3 years, and you're like, yes, I folded one, and now it's like a couple 100,000 of these things have been folded. It's just absolutely insane the kind of scale we're talking about.
The machine learning tool has made it so much more efficient to search through for problems that are search-based problems, right? Where like this can fold in all of these huge number of ways, or language can be so complex. It's really given us this amazing power to just pull out patterns, and then that ability to pull out the patterns and then use them, right? Because like now AlphaFold, some folks are leveraging that sort of like technology to like build and engineer proteins, because now we kind of understand the patterns in like the toolbox. Language, ChatGPT, like it just, you learn the patterns out and then you get to start applying them. And it's just such a cool pipeline of discovery and then application. It's been fun.
I think that's also that's the part that just fascinates me, is like there's a pure research aspect, but to some extent it's like it folds back on us humans, because there are going to be, I hope, good outcomes for us. Because if you can start to look at if you can predictively fold proteins, and you can say, oh, this would chomp, like you were saying, like this would be what this thing would do. We need something that will do that in this specific instance. Well, let's just engineer a protein that will do that. And that can have massive positive health benefits soon. I hope. I know medicine is slow, but we're going to get to that in a moment. So anyway, speaking of that, let's move on to what you're doing with your company. So you're in Nashville, is that correct?
The company is based in Nashville. But I'm over in New York, closer to family and stuff. We kind of all went remote, the last couple of years.
Exactly.
And so here we are.
Yeah, that's nice. My wife is 100% remote, and so she very much likes it. Except that she says she doesn't leave the house enough. So that's the one downside. You tend to get stoned.
Exactly. I try to escape at the end of the day. I go I basically go wander around the block at the end of the day, just get some fresh air, because otherwise it's like, been in here for days.
Are you in Brooklyn or the Bronx, or
over in the Bronx?
Okay.
Yeah.
Okay.
Yeah.
Yeah. My son lives in
We're
Brooklyn. That's
very
why I was
like,
asking. So,
oh, cool.
yeah.
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 Oh, yeah. I think I saw one of your visit videos where you went to like go visit him. I think you got to test out driving there, which
Yeah.
of
Oh
course
man.
not the easiest
Wow.
setting.
At that time, full self-driving did not work very well in Brooklyn. That was a failed experiment. So I've heard it's much better now, but yeah, New York is its own beast in terms of that. So yeah.
Yeah.
But yeah, anyway, it's just a small world sort of thing. So yeah, so tell me about Prediction Health. I have a decent sense of it, but because I don't do this kind of stuff on a daily basis, I know doctors do a lot of paperwork, but I don't know specifically like what kind of things it is and how your technology can help. So yeah, so go ahead and explain some of that.
Yeah, I'd love to. So we went through, so I have a co-founder. He was also actually MD, PhD. His name is Ravi Treya. He's delightful. Like he's such a positive, like great guy. I'm so lucky that he decided to go on this crazy adventure with me.
Yeah.
And we kind of like would bounce ideas off each other. And the punchline of the whole thing, or the core problem, is that a lot of what happens in healthcare gets just typed up, like unstructured data, like free text. Like I'm seeing this patient and I'm going to summarize what I think is going on and what I want to do. Or we're going to describe the physical exam or all these other medical things, and it's now in free text. And
so just
right? If it's free text, it's a mess.
Oppose that to like, I guess the ultimate reverse of that would be like a spreadsheet with a bunch of little check boxes that you would fill out or something like that. So this, yeah. So it's more like an essay almost that you're doing at the end. It's like, I saw the patient, they presented with this, they had these things. And so, okay, cool.
Yeah. Yeah. And that's obviously a very important distinguishing feature to draw, right? Because if you just take something and you're like, they have nausea, they don't have this, they have a headache, they're taking this medication at this dose, and you get all those numbers. There's a lot of papers that have been exploring, predicting diagnosis and optimal treatment now, like going back decades. The part where you get into trouble is because you have the essay sort of that like physicians are writing, but then you have the communication between different folks. So like you're sending messages to people like, hey, I'm worried about Mrs. Jones, she's not doing well for these reasons. And they're going back and forth on what to do. And then at like the most real time way, it's like the conversation of what's happening, because you have to go in, you see the patient. I had a professor who would say, hey, you're curious about the patient? Great, go see the patient, go talk to them, right? And look at them and like lay hands on them and understand them, right? And all of that is unstructured. And so it was funny because people would say stuff like, oh, the computer's never going to do it because like, look at all these things that I inferred. Well, this isn't really fair as a comparison because you're not giving the information to the computer even. So of course it can't predict what's wrong if you went and got a bunch of data and don't share it. But then it's very difficult to get people to punch in all of the data points for every single thing that you noticed, right? To then get an answer when they've kind of figured out for most of the cases kind of what's going on, right? So the company is basically designed to go into all that unstructured data in conversations, in the notes, in whatever we have really, and then to like try to pull out the structure. Like they do have this, they don't have that. The acuity of their problem is like this high, and like trying to put numbers on it, like their risk level or whatever. And then once you have that structured information, there's so many cool things that you can do downstream. You can do dashboards, you can summarize notes for people, you can put into different formats and try to make their lives easier, and then make sure that things are better, because humans are great and they're trying, but do you want a 97% of the time good doctor, or do you want a 99.9999? It's really hard as a human to get those nines. So I think that combining the two is how you get there, and that's a long-term dream that we would like to accomplish.
Gotcha. So the obvious question then, at least for me, is, well, let's back this up. There's two obvious questions. Number one is, this is the medical industry, and data has got to be nightmarishly difficult to get a hold of, just because of all the privacy protections and everything. So I guess first of all, how do you deal with that? Like how do you access data in an appropriate fashion in a large enough quantity? Because you can't have 3 data points, you need to have a lot. So
so you have to, of course, be thoughtful about the architectures that you're putting together. They have to be secure. You need like password protection. You need encryption, encryption at rest. Your servers have to be done, correctly. And then there's like the technical, like compliance legal components, which is you have to have the secure system, use certain thresholds. Every third-party service that you have to use has to also sort of meet that standard. And then everybody has to sign the BAA. So for it to be HIPAA compliant, HIPAA is the standard
Right.
of like, okay, this is acceptable for patient data to go in. You have to like sign a business associate agreement, which is that like, okay, I put my safeguards in place, you're putting your safeguards in place, and now we're signing this paper to sort of like agree that that's all good. And then there's the EHR companies or the other data sources, which there are not pretty APIs in healthcare. It's funny whenever we get someone from like a more traditional dev experience, right? A more traditional software engineer, they're like, hey, well, why don't we just hit the API? And it's like, oh man, dude, there's not an API.
Yeah. Great.
So sometimes there is. It is getting better, but I've been doing this now for like 7 years now, completely independent of the whole academic environment. And,
Right.
it's kind of the Wild West sometimes and pulling data in PDFs. We have a customer that gets piles of faxes still,
Oh
and you got to pull
gosh.
the data out of faxes that get OCR.
So literally you're doing optical character recognition to try to pull the information out of the faxes. So.
Fortunately, we don't have to do the OCR step, but then we get the text out and we can do predictions and normalization and extractions from that, which is cool, right? And necessary and useful, but it's just like so funny. So much of healthcare still happens in like faxes.
Yeah. I was actually just talking to another company this morning that they're working on things that will ultimately, hopefully, disrupt hearing aids. And by the time we got down into it, I was like, holy crap, hearing aids haven't changed since like the 80s. They're basically just the same thing. It's just, they've gotten smaller and more power efficient, but so they're ripe for disruption. So, okay. So you have that. And then I assume there's like multiple levels of randomization to make sure there's no way to trace it back to the original patient if for these large data sets and things like that, yeah.
Yeah. When you go to like train, like you want to like de-identify data, there's the safe harbor rules. I'll just like ever so slightly nerd out. Because if people want to go into healthcare, like please, like climb the moats and like drag yourself over here. Like we need more help. There's a lot of great things to do, but you have to get past the steps, right? And so you can de-identify data. There's like a safe harbor checklist of like, the name, the zip codes, the phone numbers, because it's not just name, right? Voice print, like the voice print component, you have to deal with because that's identifiable. So there's some hurdles to go past, but I think very worthwhile to get past them.
And that actually
cool
could
things.
be, because one of the unstructured data types that you get is actually audio from conversations that people have with their doctor. Yeah. So that's like, or even doctors themselves might not want to be identified as well. So, and oftentimes it's like that recording device that you're like, say things and somebody transcribes it. So yeah. So, wow, there's a lot of steps. So tell me about then, like at least in a general sense, and get as nerdy as you want to, but I'm very curious how you train this. I understand the outcome is like, here's this unstructured data and we're going to pull it in and we're going to say, oh, look at this. These are results that we can find. I think hypertension was one of the cases that you mentioned, near and dear to my heart since I have hypertension, but it's like we can extract this information that will show some really interesting correlations, but it's the question of how do you train it? Because it's unstructured. I mean, are you just running something over it and just saying like, well, do the best you can, or are you doing some sort of structuring to it yourselves or what?
Sometimes we get to take advantage of unstructured tools, unsupervised methods. But a lot of it has been like going through data labeling, inserting labeling into like the processes that we have. So like more concretely, physical therapy is like one of the main specialties that we're focusing in on right now.
Right.
It's super interesting too, because they have a lot of pressure, like external pressures, like reducing their reimbursement to sort of like prove outcomes. And we just, like we mentioned at the beginning, that it's kind of like this black box of messy data that,
Right.
you don't know, right, what's in there. So for example, we went through and labeled bunches and bunches of data and like iteratively trained models to do things like process this PT's note and see, what types of things they hit on, what medical conditions got mentioned, and then determine how thorough and compliant this note is. And then we put that into a dashboard. So we did a bunch of labeling so that these models could go through the unstructured text and turn it into structured data. Like, oh, you just talked about, this disease, like hypertension. You talked about the fact they have knee pain. You talked about the fact that, they did this many squats and this many that, right? And now we can take the quantified version of all that unstructured data and make a dashboard that then allows someone who has a lot of folks, in their organization to go through and be like, okay, Sam's doing great with this. Jill's having a little bit of trouble with the notes. It seems like they're a little bit more sparse in this section. There's some risk to that, or maybe this person's treatment isn't advancing as rapidly. Is a cool new thing we're looking at, because the
Oh,
rate of improvement for a patient is sort of obviously related to like how intense is the treatment and how much it's changing.
right,
Um,
right,
so once you quantify it, you can do such cool things to give people visibility in, but then to help them improve metrics that you've now
right.
pulled out of all that data for them. And I think that it's like the North Star, right? It's like the compass that you don't have in
Yeah,
healthcare if so much of the data is kind of hidden in this like black box of unstructured stuff.
right.
And making that visible, I think, is a really big lever to improve the quality of the care, but also the efficiency of the care.
Okay. Okay. And did you have like an example of that, like some sort of a demo thing that you could, because I have a feeling just at least for me, it would be helpful to like, or was it something else? But I'm always like, I'm kind of visual. I'm like, oh yeah, okay, now I see what you're talking about. So
Yeah. Let's see. What can we do? I've got like a slide demo-y thing.
sure.
We can like stop now and I can pull it up. It'll take me like 30 seconds though,
Yeah,
probably.
it's fine. I'll just cut
Or
this part. Don't worry about it. Yeah. So yeah, you should have
so
access to sharing the screen. So you should just be able to share whatever window you want to.
sweet. I think this is like one of the coolest things still. So here you just have like sentences that you'll pull out from the note. And there are all these great language models now. And I guess now most people know about ChatGPT, right? But there's been a lot of language models that have been developed over the years that can
Right.
take text, all this unstructured stuff, and then learn to predict certain useful things. So we're running this whole process for all of these notes and all this data extraction that we do that will go through and then identify, what type of statement is this, and what types of statements do we need, right? And how thorough is it from
Yeah.
it. So patient reports no new complaints. It's a negative signs and symptoms. And HPI would be history of present illness, which is them kind of describing what's going on with their disease. But then they're going to talk about, what are they trying to functionally do, and what can they do, and what can't they do?
Right.
Because that's really important to say that your intervention is medically necessary. You have to be able to say, that it's related to a key functionality, like going up and down stairs, being able to walk, certain distances, being able to like pick up your children. And
Right.
if you aren't strong enough, if your shoulder hurts, you can't do that. You can't take care of them. And so, because of the way insurance is and everything, you kind of have to take these things into account and be able to justify that you're helping the patient do a task, do a
Right.
function that is important to daily living. And so for this next one, you can see that it's kind of smeared across three things. How blue it is how intense that statement is in that category. So able to ascend and descend a flight of stairs without pain in his knee, negative key findings, negative signs and symptoms, and activity limitations are all getting some signal here.
Okay.
And that's also a really cool thing about language is that in one sentence, you can hit on a bunch of different topics. And
Right.
so when you do that translation to the vectors, to the numbers, you can't just assume like, oh, great, this is going to be a sentence about symptoms, right? Even if it's not a
Yeah.
run-on sentence, it could easily be like a bunch of stuff, which is really, really cool.
And I really I think that's very clever. The color coding for confidence is very, because it's one of the problems a lot of times. In fact, a lot of times, even people with ChatGPT, they're like, there's no insight into the level of confidence that it has as it's, writing its
Right.
chat with you. So that's very clever. I really like that a
Yeah.
lot. Okay.
Yeah, you can even do token level. So you can go through the words even and
Right.
find like the hot spots that are contributing to each different thing. Because there's like the without pain in the knees, that's going to be more of the activity limitation and
Right.
like the ascend and descend, maybe, right? So that part's really cool too. And then we go up. We go up a layer. Here. So we do all that processing
Right.
for all of the notes. They go in, we do all the predictions. We have a bunch of different models and new ones that we're getting ready to launch and add all the time. And then we present it back in the dashboards, which is just so critical because you're not going to sit there and read a million notes. But if I
Yeah.
give you a dashboard that focuses on like, these people are a little bit more compliant, these people are being less efficient, they're putting in time and they're doing work, but maybe somehow they're not billing for it, lots of different reasons that you would care about. They're not justifying medical necessity, like yikes.
Yeah.
You can help them then like pinpoint,
Right.
um,
Wow.
yeah.
Okay.
So
Super interesting.
it's been really cool.
Yeah.
And I think PT's they just have so much pressure and they have this compliance thing that's kind of unique to them, which I thought was interesting. But we would then love to spin this out and go do family medicine and ortho and neurology and
Right.
all these other specialties. They just have different types of problems that will need to be optimized in sort of different ways and sort of like less acute pressure compared to sort of like what I've seen, at least in PT. So,
right.
It's a good starting place.
Is the acute pressure just because of the intensity, like the time intensity of doing PT? Because you could go to visit a doctor for a half an hour and they can diagnose you and you can go off and do your own thing. But PT is a pretty, it's like an hour 3 times a week or something. So there's a much more intensive type of interaction, I guess.
Yeah, I can't. I'm largely like speculating, but it seems like there's just a lot of pressure. Like it's hard for folks to quantify the value that you get from it. I think it's pretty obvious there's benefit, right? Because you have a really important surgery and you don't do your PT, like, you're not going to heal as well. You're not going to get that strength back. But like quantifying that and pulling that out in a way that you can easily justify it back to the person that's going to pay, like the surgery is like, one and done, and like I replace your joint, and it's just like, okay, like it seems like people have like an intuitive grasp of that being like a big deal. But for some reason, maybe because it's like I can go to the gym by myself, like people seem to underweight the importance of the PT side and like what is the PT doing? Like, so there seems to be a gap there that if you could pull the data out and quantify and show how much better the outcomes are, I think it would be a lot easier then to convince folks that this is totally worth doing. And these people here are super efficient at getting great outcomes, and people are healing their knee issues faster. They're coming back from surgery sooner, or they're avoiding surgery. There's a lot of times where you can avoid the surgery by doing the physical therapy. But like it just gets undervalued, I think. And I think we can bring the quantification that makes it a lot easier to show the value of doing those things.
Cool. And again, I guess one of the problems is the output data is relatively unstructured, but also the physical therapy, even though there's very distinct things that you're supposed to do, it's again, not like a surgery where it's like, well, patient lived, that was a successful, knee has been replaced, patient didn't die, good outcome. This is a much more extended and, kind of, you don't really know. It's like, well, yeah, it's better than the other one. So it's kind of relatively speaking, it's better, not absolutely. So yeah, so that's great. So I was saying just a minute ago, I guess with the part that we cut out here, but I was curious what you think, because so I've been in the same thing because I've got a small startup company myself. It's a couple of years younger than yours, but coming from academia, coming from research, there's been a lot of things to learn about. So I'm curious what you have discovered of the business of doing machine learning, the intersection of healthcare and machine learning. It's got to have some really interesting lessons for you. You were talking about venture capitalists and people interested in funding the company, and some people are interested in one thing. Other people are just like, when do I get my ROI? So yeah.
Yeah. So there's so many lessons. I think the one that sticks with me the most, and that I'll mention first, is that it's just not intuitive. There's so much that my co-founder and I thought in the very beginning when we were just, like literally working out of his like spare bedroom, like coding things up and trying to figure out what to do, that, it's not about how pixel perfect that first design is and that prototype. It's about putting it in front of people, and then your objective function, to sort of like be a nerdy ML person, right? Like your reward function is, do they value it enough that they will pay for it because you're making their life so much better that like, of course this is worth, some dollars, and here you go. Especially because people are nice, and it's really nice that people are nice, and especially in academia, which is where we sort of started off, right? So they don't want to like crush your dreams, so they'll give you good feedback and like, oh, this is fun and this seems nice. But then if you go into like, well, would you use this? Does this make like your life easier? Then you get the real answer, just like, oh, it doesn't quite fit my workflow, which you want to know as fast as possible, because you basically want a good signal of like, am I delivering value? Am I making someone's life better? And then you want to then improve that as fast as possible. And nice feedback is nice, but it is not efficient at figuring out what is not good about this that I can fix. And like that's, I think, the core lesson of the whole thing is figure out how you can get answers and then iterate quickly and just specifically hone in on what is not good about this. It's not efficient enough. It's not fast enough. It doesn't fit in my workflow because of X, Y, and Z. And then you try to crank this wheel of, okay, what's the fastest, most efficient thing we can do to address that issue, and then put it back in front of somebody. And that's always not like the most polished thing, because that's like the stuff that you get to worry about later. Early on, it's like, does it run? Do I save time? Is it accurate enough? Because some use cases, it's 80% accurate. Great. Some use cases it has to be 99.999% accurate. And that threshold is, you don't always know ahead of time exactly what it is. You'll have a sense if it's higher or lower, but you won't always know like, oh, I clear 89%, like we're usable, right?
Yeah. Or not. Yeah. I mean, I think that's one of the reasons people, that I talk about Tesla a lot and full self-driving and the autonomous driving. And I think one of the reasons that it has been so excruciatingly slow is that the bar of 90% was passed quite a while ago, actually, but that's not nearly good enough. We're talking 99 point, a bunch of nines after that it has to work. And every time you want to go another order of magnitude closer to 100%, it's just the amount of work is crazy. You get that diminishing returns where you get these tiny increases of value from a huge amount of extra work. So yeah, so I could certainly see that being something. But also I think that's a good sort of point to remember is it's like people will vote with their dollars or whatever currency they're using. It's like, are you willing to spend money for this product? If not, then clearly it's failing in some, at least if it fits your market, right? I mean, obviously, if you're a school teacher, then probably healthcare products are not something you're going to buy. But indirectly, if you have a healthcare problem, then hopefully your doctor is using it. So,
that one's just so critical because it's not so much about even if you had infinite dollars, right? If you somehow raise the most money in the whole world, if you want to figure out as fast as possible how to make your thing useful, or is it useful, you just put any sort of dollar figure on it. People are going to give you a much more honest answer about, is it delivering value? And like, that's the key.
Yeah.
Otherwise people are nice, which is good, but
but I like thinking about it as an objective function. That's the loss function, the whatever. It's the way that machine learning, it's how the teacher smacks the student with the ruler. It's a thing like, you're not doing good enough right now, do better. And I think you're right, because we humans, of course, being social creatures, you don't want to go like, you don't want to be rude and tell the person that they're doing a terrible job. So generally you'd be like, you're like, oh, that's wonderful, that's a great product. And it's like, how much are you willing to pay for it? Oh, I don't know. Then you get the opposite end of things. So I think you're right. It's a way of learning more quickly, because it's like, what are people willing to pay for? So I don't know if you've discovered, for me at least, things seem to have gone a lot slower than I expected. I don't know, I've been in academia for a long time, and so not in business as much. And I would look at these businesses and go like, why can't they go faster? They should be able to knock this thing out in 6 months or something, and it should be all great and working. And now that I'm more into it, I'm like, holy crap, this is slow. There's just so many weird side things that you have to deal with that have nothing to do with the core product, that, just to operate a business.
Oh, yeah.
So, yeah. Like, what is your role?
No, so true.
You're CEO. So, I mean, you're the guy who wears all the hats. It's like, today you're marketing, tomorrow you're technology, the next day you're customer service issues, it's like whatever it takes to get it to work right. So yeah.
It's totally true. You just kind of like have to do what you have to do. And you're not going to start a startup if you're not an optimistic person, because it's already a high risk endeavor. So you have to be like a very optimistic person to even bother. And so you try, and I feel like that optimism bleeds into your timelines. And there's a class of there are people that are very comfortable with that. Like, okay, we tried hard. We set an aggressive timeline. We didn't hit it, but like, we're making progress. We're going to get there. Right. And then other folks, like, missing timelines is actually very, very demotivational. And once you go past that initial, two guys in a room to, 3, 4, 5 people, a team of people, you now have to do a lot more management. And it's interesting that you can iterate super fast when you're small, but then you can't do other things really well. Like, at some point you have to scale, and the things that are needed for scale and the things that are needed in the beginning to iterate rapidly for each new thing are very different. And then the friction points and challenges are very different. And you have to somehow balance sort of both parts in one company with one team of people and very limited resources. And that's the kind of wacky thing, right? It takes so much longer. So then you have to learn how to prioritize and keep scoping down. And it's like, this seems ridiculously tiny. And it's like, good, chop it down some more so that it can get done in a couple of weeks. Right. Because even that's going to have stuff that blows up on you. And the best people that I've seen are just really good at scoping. And when I was younger, I'd be like, this seems so not ambitious. But
right.
that was because now you're actually going to get something to work, and then you can build on that. And that
Exactly.
was an important lesson that took me a while to figure out.
Yeah. I mean, I've discovered that about myself. I tend to be always looking like 10 steps down the future. And it's like, no. You got to focus on like this thing right here. So yeah.
Yeah. It's so hard to do, but it's fun, right?
Right.
I totally get it. I love it. I love just like brainstorming and throwing features, and we'll come out of a room where we're supposed to meet about one thing and we've got 5 other ideas. Right. And it's like, okay, we got to shelve those
exactly
for a second. Gotta finish this.
It's kind of the way it works. You have like a little like a table of things for future. So I mean, heck, I'm teaching a game class, like an advanced game class this semester in my real day job, and we're doing agile software development, and every time we get together, this game keeps expanding into this giant thing. And I'm like, no, we've got 15 weeks. Bring it back down again, right? You have to focus on, it's like, so we have this like all these lists of like version 2.0 of the game. We have like the gigantic wish list, but in the meantime, it's like, this is what we can do in 15 weeks, so that's the kind of thing, but it's fun because you're right. I think that's a really, really fair and really good thing for people to sort of, especially if you're younger. Optimism is a really, really powerful tool that people really underestimate. If you take it to the extreme that you have absolutely no optimism that the world's going to exist, why would you get out of bed or eat or, any of that stuff, right? So there's a level of optimism which just gets you out of bed in the morning. But I think the most successful people are also a little bit crazy and the most optimistic. And that could actually exactly explain the reason why timelines often get missed, because it's the exact kind of person who's like, oh yeah, we can do that in 6 weeks, no problem. And a year later, you're like, oh, that was a lot harder than I thought it was going to be. So, but you still made progress, so it's okay.
Yeah.
Yeah.
Exactly. Yeah. So you got to track something, but
yeah,
it's just wild. Yeah. You got to try and you have to keep going.
Right.
And if you're at least kind of roughly moving in the right direction, if you at least try and then keep going long enough, then something cool probably happens, right?
Yeah. Yeah. And you never know what it is. At least you're opening yourself up to the possibilities. So let me broaden away from the company itself and talk to me about, because I'm sure you at least keep some sort of eye on AI and technology and stuff like that. What do you think? It seems like the last year or 18 months has been a little bit astounding to me, just in terms of like the range of different massive improvements in machine learning outcomes. So I don't know, maybe you don't think that way. Tell me what you think about that.
Oh no, I feel like it's been accelerating. They have the great like old video of the people in like those rocket like experiments, and you can kind of see like their cheeks getting pushed back because they're accelerating so rapidly. And I just feel like from an academic like technology like ML AI perspective, it just feels like it's getting like worse and worse, like faster and faster acceleration wise all the time. And you can just scroll through, social media now if you're following people that are nerdy scientists, and it'd be like, oh, new state of the art. And then you scroll a bit further, like, oh, here's yet another new state of the art. And it's like, I didn't even get a chance to try the first one.
Right, exactly. And then, it really gets depressing trying to keep up with research and stuff too. I hate to say this, but I've started using ChatGPT as a summarize this. So I'll copy a big chunk of the article and I'll be like, summarize this, because I don't have the time to really like sit down and think, unless it's something very specific to what I'm doing. But just the more general articles, it's like, I don't have the 2 or 3 hours that it's going to take to really dig through this article.
Yeah.
So, yeah.
Yeah, I totally agree. My current workflow for, when I get to do some sort of engineering R&D, type thing is, Visual Studio Code. And then I've got Copilot going in there. And then I've got ChatGPT up. And it has been totally ridiculous because I would, you go to Stack Overflow, you go search, you go look at the docs, you go try to figure out how to do it, you test things out. And instead I want to do this. And either I write the comment and I get the code auto completion, or I ask, ChatGPT to just refactor this for X, Y, and Z. Like, oh, I don't remember how to do this in JavaScript. Like, can you please make me a thing and then change the button color to blue or whatever? And it just bangs it out. And it's like, wow, this is awesome. And this is just getting faster. Like, I don't know.
And better. I haven't had the chance
cool.
to use Copilot yet. I really feel like I should. I mean, I've messed around with ChatGPT where I'm like, write me code that'll do this. And it's like, well, that's pretty cool. And when it makes a mistake, the cool part is you can feed it back in again and say, what are the errors? And it'll find them, which is the really crazy. Exactly. So it'll actually do, bug squashing too. But yeah, it sounds like Copilot's really pretty impressive too, that it will do a lot of the coding for you.
Yeah.
So.
Yeah. It's really nice that it's integrated into like the IDE. I was like very much like a notebook fan because it's interactive and everything.
Right.
But the fact that you have that and you can do the comments and get that in line, I haven't found a really great one for notebook integration for that. But like that's been really killer. But I still feel like there's something about the interactivity of ChatGPT and like dialogue where you can explain to it a little bit more naturally, like I want this, that, and the other thing.
Right.
And it just does a really great job of inferring intent, but then also you can point it at a chunk of content and get it to like refactor. And I think people are building like tools that will help and embed this more into the other workflow. But it reminds you how awesome the dialogue thing is in healthcare. Like you usually see things fail because they need people to like click or punch buttons or whatever.
Right.
But folks are very comfortable in healthcare, just like turning over to if they have a scribe or an assistant, right? And be like, hey, I need this Y and Z for Mrs. Jones, and then we got to get her these medications. And it's just like this great interface that they always want to stay there. And I get it, right? It's very natural, assuming the person that's listening actually interprets the correct intent, right?
And that of course is always the sticking point, is when it makes a mistake. Again, that's that accuracy issue. Not that doesn't happen with humans too. To date myself, I'm old enough that I did a summer temporary job. Oh gosh, either in college or grad school, where I transcribed medical records. So back in the day of the little tiny tapes, that they would push the little tape players, and you had like 2 foot pedals that would go forward and backward at different speeds depending on how fast. And I don't have any, certainly not back then. I had no medical training. So they're saying these words and I'm like, I don't know. It sounds like what they said was this, so even we humans are not perfect at doing things like transcription, but there is a level, 90 something +% accurate that this has to be before humans will trust it. Because otherwise they're just going to say like, no, it makes a mistake every time I throw in anything interesting. Therefore, I have to go back and fix it, which takes as much time as like trying to just doing it a different way in the first place. But yeah,
exactly.
But they're getting better and better. So I don't know.
Yeah.
So what's the next?
Eventually, we'll get there.
Like from machine learning, what do you think the next one's going to be? Is it going to be you guys? Right? That's it. That'll be it.
We'd like to try. That obviously would be really exciting. So we'll have to see. But it's, I'm now a little bit, maybe a tiny bit wiser in that it's probably going to take way longer than even my most conservative estimates. I'm like, okay, we'll keep pushing on it. I think it would be really cool to see integrations of something like ChatGPT into more workflows. Like imagine an EHR where instead of like me getting code out, I can kind of like update something to ChatGPT, and we may or may not be exploring that kind of thing. But I think you're going to need some fundamental improvements in the tech that are still kind of research questions, like how factually accurate it is, or could you at least like pinpoint when the fact is inaccurate? And that one's really cool because people are experimenting with great things there. But I think you're going to have to figure out how do you put how factual something is into that objective function, right? That like as I'm training, I'm not just doing things that probabilistically like the next word makes sense, but also that the factual accuracy or the consistency. Like I'm not contradicting myself in like the same paragraph, which you will see. And that's like a really cool problem. I think that's going to be key. A little bit more interpretability into the models probably. And then I'm sure I don't know what I don't know, right? I'm sure there's a couple other things that are going to need to be done in healthcare. But once that happens, I think you're going to have huge pickups for people taking care of patients, to find people earlier on. And then you're going to hit some other kind of wacky bottleneck. And I wouldn't be surprised if that next bottleneck, once the AI thing is really crushing it, is that a lot of the things that we label a certain way are not accurate categorizations. Like just because you call something diabetes doesn't mean that every single person that has diabetes has the same reason or set of reasons for their diabetes.
Right.
And that always drove me nuts in med school, because it's like, okay, cool, we're treating these people all the same. But then I was also doing a lot of protein stuff, and I was seeing it like, oh my God, this disease has like 100 different mutations that will contribute to it, or a mix of them. And like, we're just lumping this thing under this. Oh, yikes.
That actually is rather exciting, that the healthcare for an individual patient can become more individualized rather than like you fit in this bucket of diabetes. It's like, well, actually you're this tiny little corner over here. So yeah, that could be really, really nice. And hopefully again, we'll have really good health outcomes for patients as well. Because that if you can get a more individualized treatment, that's going to help, I would imagine, your odds of survival. So yeah, very, very cool.
Hopefully, yeah. You could imagine that the entire circle of the patient visit is like they come in, they have some problems, and you have an AI listening and helping to write the note and structuring that. And then, you grab all the genetic data, and then you have AlphaFold folding all of their proteins that it doesn't already know what the structures are. And then something else predicts like the assessment of if that's going to impact function, and then what the network of all of those proteins, interact with each other is going to yield that may be relevant to their current symptoms. And, like shove in some more models and some more craziness, but like that could be, I think that's the future of medicine. If you're like jumping forward, is this whole like quantifying loop where you get to take advantage of these tools and kind of connect them all together and drill down to like what is functionally wrong. And also very rarely do you find like the bug.
Yeah.
I always joke. I may have fixed one of the bugs. And
right.
I think healthcare is going to be similar, or diseases, patient health is going to be similar. It's like we may have found some of the mechanisms that are causing your disease or environmental factors or whatever. And hopefully we find and understand enough of them and can actually influence them so that we can get you back to feeling great, So.
Yeah. That's the other part is just not just the ability to do diagnostics, but then to actually intervene and make changes that can be positive. That would be, I mean, just doing diagnostic on its own right, just getting it right would be a huge step. And then, I mean, I can't tell you like so many, there's always those anecdotes of people that that are like, I had this and I went to 15 different doctors and they were like, no idea what this is. Try this, nothing worked, right? Just getting the diagnosis for these things and saying like, yep, this is the 5 things, right? Because it's this weird combination of 5 things that's causing this bizarre problem. And the only way you would know is from like having, hundreds of millions of medical records and being able to like cross-reference those things. So that would be huge. But then being able to engineer a solution to it too would be the next step. And that would be pretty darn amazing. So, yeah.
I remember there were some papers on misdiagnosis rates, and this is kind of old now. This is maybe like 6 years ago, but estimates were like 5 to 15% of folks going in to get some sort of like what's going on. Like misdiagnosis rate could be up in that range. So it's like 1 in 10, 1 in 5 people. It's kind of like nuts to consider, but like it's on that order of magnitude, which is scary. But we need other tools to help. It's a solvable problem, maybe is the way to look at it, to be more optimistic.
Yeah, I think so. I mean, that's the cool part about it is, and that's one of the things that, even though it doesn't seem like, something like DALL-E 2 that makes pictures out of text, it doesn't seem like it's related, but it actually is. Like all of this stuff is being able to pull in enough information to train those little weights, all those little guys in there to make sense out of it. And I've told people before, I did like a much simpler, like a super old, I think you used random forest too. And I believe it was a random forest we used, but it was that thing you had, like, it was a toy problem that had like 20 symptoms and all the diseases it could be with the different combinations. And you could train that sucker up in no time at all. And it would be like 99.9% accurate in diagnosis, but it's really easy when you've got little check boxes where, because the problem is, it's like, if somebody presents with diabetes, what does that mean? And what levels are we talking about? And exactly how much sugar and what's the different, nothing is as simple as like, check, you're done with this symptom. So,
yeah. I feel very fortunate that I got to do the whole med school adventure, because you learn so many things that were not obvious to me, at least. And it's stuff like the way someone answers a question, like same exact thing. They can use the same exact words, but some people are really stoic and they'll be like, yeah, I'm totally fine. Or just like a little bit, but like, you're looking after a while, you start trying to like look at them and like, oh, you actually seem like you're really uncomfortable right now. So you're telling me 2 out of 10 pain, but like, I don't really believe you. And also, I'm picking up that I'm trying to do the physical exam to figure out like where this pain is, but you're so guarded that like, it's not 100% obvious. So like, there's all these little like hidden levels that even if they just told you check the box, the box check could be wrong
right.
because you have to assess what this person's going to tell you, and people are going to vary so much. They're like, "Oh, I'm this is the worst pain I've ever had," or "This is like nothing," and it adds so much noise to like the check boxes that you would fill out.
Right.
It's a fascinating problem.
Yeah, we human beings are just darn complicated. We can't even give you like, if you're like on a scale of 1 to 10, I go to the chiropractor and it's like, what's your pain level? And I just always circle like 5 or 6. I'm like, I don't know. It's some pain. It's like, I don't really know how to judge from that stuff. So it's not a particularly useful metric in that case. So yeah, and whereas other people might say 1, like no problem, I got this, and other people might be it's like the worst thing ever, I'm dying, it's 10, it's 11, so so yeah, it just seems like it's very what's that, pernicious. It's like really, really difficult to get at the root of the problem because it's so difficult to describe the symptoms. So yeah. Very cool. All right. I don't know if you had anything else to say, but I've had this has been really, really fun chatting. It's like, get to talk about business, about machine learning, about healthcare. Healthcare, I hope is interesting to everybody. I can't imagine anyone who's not, even if you're healthy right now, sometime in your life, you're going to have bad things happen to you. So I would imagine it's important. So I hopefully people will be very excited about companies like yours and in trying to improve outcomes for patients through this. This is a great tool. It makes the singularity less scary, right? If the AI is there in service to us and trying to help us. So
lots of opportunities to make things better. And healthcare is intense and it's tricky and it can be scary to face all of that. But I like to encourage people, health is so important, and it's an industry that you can make a really big impact. And so, with AI or ML or not, or just easier processes or lots of other stuff too that I'm not as specialized in, but they're still important. Yeah.
All right. Cool.
And,
Well, thank you so much, Pedro, for joining me today. I really do appreciate it, and I hope folks like it. And of course, if you want to leave questions, or hopefully not medical questions like, hey, I've got these problems, what's my diagnosis? Maybe not that. But if you want to leave your thoughts in the comments, that would be great, and we can read them and get back to you about that. Anyway, in the meantime, everybody have a wonderful day, and we'll see you later. Bye-bye.